Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe the effect of changing the temperature on a reversible reaction at equilibrium. And this is for higher tier students only. Now I should point out that some students find this tricky. You might need to watch this video a couple of times. In the last video, we looked at Le Chatelier's principle. This states that if a system's at equilibrium and a change is made to the conditions, then the system responds to counteract the change. We looked at the effect of changing concentration on reversible reactions, but in this video, we're looking at the effect of temperature. Take a look at this reaction, which we saw in the previous video. The reactant NO2 is forming the product N2O4, and this is a reversible reaction. Now, a key point about this reaction is that the forward reaction is exothermic. What that means is that when the forward reaction takes place, energy is released and the temperature of the system increases. Remember that in a reversible reaction, if the reaction is exothermic in one direction, then it's endothermic in the opposite direction. So in this case, the reverse reaction must be endothermic. What that means is that when the reverse reaction takes place, energy is taken in and the temperature of the system decreases. Now I should point out that every reversible reaction is different. Some are exothermic in the forward direction and some are exothermic in the reverse direction. In the exam, you'll be given all the information that you need. So the question is, what happens if we increase the temperature of this system? Well, as we said before, if we make any changes to a system at equilibrium, then the system counteracts the change. So if we increase the temperature of this system, then the equilibrium shifts to the left to reduce the temperature. That's because the reverse reaction is endothermic, so energy is taken in, causing the temperature to fall. So in this case, the amount of NO2 would increase, and the amount of N2O4 would decrease. So what would happen if we decrease the temperature of this system? In this case, the equilibrium shifts to the right to increase the temperature. And that's because the forward reaction is exothermic, so energy is released, causing the temperature to increase. So in this case, the amount of N2O4 would increase, and the amount of NO2 would decrease. Remember, you'll find plenty of questions on the effect of temperature on reversible reactions in my revision workbook, and you can get that by clicking on the link above. Okay, so hopefully now you should be able to describe the effect of changing the temperature on a reversible reaction at equilibrium.